I record all these sessions, so you'll
Okay.
get access to a file that will let you replay this tutoring session.
Okay. So the first thing we actually sorry, one second. I left something behind. Let me go get that really quickly.
Okay.
Okay.
And
Sorry.
just before I forget, that control panel, the GoToMeeting control panel, you can minimize that if you click on the two arrows that face one another. That will shrink it up so it doesn't take up so much of your screen.
Okay, perfect.
Without.
All right, cool.
Okay.
Okay, so the first thing we learned was let's see if I can. Okay. 1 second. Okay, there we go. So the first thing was just solving limits graphically and numerically, and it was just it was just like the normal direct substitution graphically, and then like something like
graphic is something you're going to need to send me a picture of. I mean, I can I can do stuff like this, and I can say to you, you know, here, let me just do this real quick, make sure you understand it. So with the function that I put up there, what is the limit as we approach, as x approaches 3 from the left?
As x approaches 2.
Okay, what's the limit as x approaches 3 from the right?
5. And this means, I mean, if it was x approaches 3, it would be, I mean, yeah, it would, the limit would not exist, right?
Okay, that was my next question. Yes. The only way the limit exists is if it exists, if it's the same thing from the left and the right. Now, let me give you another one that really illustrates it really well. This is your hyperbolic function, y equals 1 over x. What's the limit of that as x approaches 0 from the right? Can you hear me?
Okay, now I can hear you. I couldn't hear you for a couple minutes. I was just opening the chat window, so maybe I could text you, but now I can hear you.
What's the limit of this hyperbolic function as x approaches 0 from the right?
Infinity.
What's the limit as x approaches 0 from the left?
Negative infinity.
So what's the limit at 0?
D does not exist.
Okay, now let's change the function slightly. And now the function looks like this. Because I made it 1 over x squared. So now what's the function, the limit as we approach 0 from the right?
Infinity.
And from the left?
Infinity.
So the limit of this function as x approaches 0 does exist.
Yeah.
And it's infinity. So a lot of times they will interchange does not exist, infinity, and undefined. But there are definitely differences to those three terms.
Yeah, so this was one of the things we learned was graphically, and then it was also numerically, just direct substitution. And then it was also, we recently learned properties of limits and direct substitution. And then they talked about like scalar multiples, adding and subtracting product, quotient, and then also the special trig limits, and then it was hold on, and limits of composite functions.
Okay.
And such.
let's take
Yeah.
the basic methods for solving for limits numerically or algebraically.
Mhm.
How would I solve this problem right here?
So you can't plug in, you can't do direct substitution for this, because if you did, it would be 0 in the denominator, which is undefined.
Right.
So you would have to simplify. You would first have to factor out the expression on the top, which is x squared minus 1, which is you can factor out to x plus 1 and x minus 1, and you can cancel out the x minus 1 on both on the top and bottom, and you'll end up with x plus 1. You can substitute 1 in for x plus 1, and you'll get 2.
Okay. So you've realized that the only difficult limit problems are the ones that result in 0 over 0.
Yeah.
If I end up with a number over 0, that's going to be either infinity or undefined.
Mm-hmm.
And if I end up with 0 over a number, that's just going to be 0.
Yeah.
And any other combination gives you a number. So the only ones that are tough are 0 over 0. All of them that you on a test will be 0 over 0.
Yeah.
None of the others are even worth talking about. Now, they will probably tell you to memorize this one. This one's not.
Yeah, sin x over x equals 1.
Yeah.
Limit, yeah. And then they also had sin x over x equals 1, and then limit as x approaches 0, 1 minus cosine x over x equals 0.
Yep. And they have you memorize those because you don't have enough math yet, you don't have enough calculus yet to really prove this to yourself. And you won't get that calculus for another few months. Once you get into more advanced calculus, you'll learn L'Hopital's rule, and it's real easy to prove why the limit of sine x over x is equal to 1. But if you were to graph that, the graph also gives you fairly strong verification that it's equal to 1. In other words, that graph right there is sine x over x. And we can see that as we approach 0,
it goes towards 1. Yeah.
1. Yeah. And the same with this, only it goes to 0. So you could see this graphically, although that is not really mathematical proof, but you'll learn that later. So they do ask you to memorize these two, and then everything else can be done using algebra.
Yeah.
And there are really 3 main ways to do these, and only 3. One you already did, you factored. Okay? A second one would be, let me look one up here.
So one thing they did teach us, well, they kind of taught us was, so it was a limit as x approaches 0, and then they had radical.
That's what I was looking for. I just found one in my book.
It was like complex conjugates or whatever. I mean, conjugates. Using conjugates.
That is the second primary method to use, is where you multiply top and bottom by the conjugate of wherever the radical sign appears. In other words, here we're taking the limit as x goes to 4, and obviously we're going to have 0 over 0 with direct substitution. And it's not an E. If you didn't know about multiplying by the conjugate, I'm not sure one would figure it out. But that is the trick. In other words, you can multiply any fraction by the number 1, and my number 1 is going to be this.
Yeah. And you would do that on both sides, and then you would simplify, and you would get...
And what happens is after you do that, it no longer becomes 0 over 0. In other words, if you multiply the top in an easy way, since this is basically difference of squares factored, an easy way to get that is it's x plus 5 minus 9. In the top, And the bottom, we're not going to multiply that out. There's no need to. We're just going to leave it like this, because when we resubstitute, we won't have 0 over 0, and that's the key. What did I do wrong here? Because I do have 0 over 0 still.
I think you just have to distribute, and then you'll probably get the right answer.
No,
like
I distribute, because when x goes to 4, this, yeah, no, you're absolutely right. If I simplified it, that becomes x minus 4.
Mm-hmm. And you can cancel it out on both sides, yeah.
And that's usually the way these limit problems work, is you end up getting a common factor in numerator and denominator. You cancel it out, and now if you substitute, it's no longer 0 over 0. It is 1 over
1 over 6.
Yeah, 1 over 6. And that's what that limit is.
Mm-hmm. Okay.
Okay. And that's the second main way, and that would handle almost all of your limit problems except trig functions.
Mm-hmm.
And
yeah, so for trig functions, some of the problems that they kind of gave us were like,
do you have one?
Sine. Actually, could I send you a couple of problems for my homework last night that I had trouble with?
Absolutely.
Okay, 1 second. Let me just
write my email address here so you don't misspell it.
Okay.
Don't send it to my phone, send it to my email.
Okay.
That way I can bring it straight up on my computer screen here.
Okay. So, what's your email? Okay, David, I see it. David Cohen 1949.
Yeah.
Okay. All right. Oh, okay. 1 second.
And once you've sent the file, just tell me you've sent it, and then I'll open up my email and retrieve it.
Mm. 1 second. Okay. All right, I just sent it.
Okay. Did not get it. Let's see.
I might take just a second for my computer to send itself because I'm actually I don't have. Oh yeah, it's taking a while to send. Sorry. As soon as it sends, I'll let you know.
I'm sorry, I didn't quite hear what you were saying there.
Oh, sorry. It just sent.
Okay. Yeah, it has to say sent on your end before I can get it.
Yeah.
There it is.
Okay, there we go.
Okay, which one do you want to look at first?
Like it's the first one.
Can you see the 3 on my screen at the bottom?
Yeah.
Can you tell which one you want to look at first?
The first one, like the yeah, that one. Mm-hmm.
I think I can just blow it up here. Okay, sine x over 3x. Yeah. You knew how to do
that one. Yeah, the one right under it, which is limit theta goes towards.
Okay, all right. So we got cosine of 8 theta, tangent of 8 theta, all over theta, right? Cosine
to get like
Here, let me write this out, and then we'll do it. So it's cosine of 8 theta, tangent 8 theta over theta, and we're taking the limit of that as theta goes to 0, correct?
Yeah.
Well, the tangent of 0, of 8 theta, is certainly 0. What's the cosine of 8 theta? Well, that's going to be 1 normally. But since it's multiplied by 0, I end up with 0 over 0. Okay. Well,
so I would
let's use our trig. Let's use our trig.
Yeah, sine over cosine, correct? And then I could just cancel out the cosine on both sides, and then I would get sine theta, 8 theta over theta. But then how would I reduce it from sine 8 theta over theta to something?
We're going to take the limit of that as theta goes to 0. And we know that if I multiply top and bottom by 8, like that, now I can take that and know that that goes to 1.
Okay.
And 1 times 8 is 8. So the limit of that is 8.
Okay. So I also, hold on 1 second. Can you still hear me?
Uh-huh.
Okay, 1 second. I actually, so even those problems weren't, like, I ended up figuring them out, but I wanted to do my homework with you today, because that's usually where I have a lot of trouble, and I end up asking like my friends or whatever, but I don't want to have to rely on that. So if I could just like send you all the problems in my homework, and if you could just like help me out with some of them, that would be awesome.
This first session is only a half an hour, and we only have 5 minutes left.
Yeah. Do you mind if I just send you the first problem?
Yep. Can you just read it? It might be easy.
Oh, yeah, sure. Yeah, that is easier. So the first problem is, okay, the first problem is just about graphs. Let's see if I can find the word that I needed.
Now that's hard to verbalize. You're going to have to take a picture.
Okay.
Graphical. Go ahead and take
I have one now. So here's the problem I need help on.
Okay.
So it's limit delta x approaches 0 from the right side. And then the function is 9 over, it's a compound fraction. It's 9 over x plus delta x minus 9 over x all over delta x.
X plus delta x minus 9
over x, and then everything over delta x. Oh, no. It's not x plus delta x minus 9. It's 9 over x plus delta x, and then a separate fraction minus 9 over x.
Okay. I get you now.
Yeah, like that? And then, and then this entire fraction over delta x.
All right.
Yeah.
The way you do these problems is by finding a common denominator in the top.
So it would be x and x times x plus delta x. You would do that on both sides.
Yep. So here, let me write just a little bit smaller. Here's the way I do these. Here's my common denominator. What's the top left?
The top left would be 9x.
Okay. And what's the
and
top
then the 9 times x, well, 9x plus 9 delta x. Oh, that's distributed. Yeah, 9 times x plus delta x.
You do need to distribute that. So basically, the numerator of the numerator becomes minus delta x.
Yeah, all over x plus delta x over x.
And it's better never to distribute these in the bottom.
Okay.
Just, you end up going backwards.
Yeah, canceling out because of common factors, yeah.
Yeah, and there's a 9 here, I guess. Okay. And then if I'm dividing that by delta x, that's the same as multiplying it by 1 over delta
x.
And again, those go away. And we end up with minus 9 all over x times x plus delta x. Now, as we approach 0 from the right, what does this go to?
It'll be minus 9 over x squared.
Well, oh,
I
okay.
think.
Yeah, no, you're absolutely right. Minus 9 over x squared, yes. What they're really kind of doing here is getting you ready for the limit quotient definition of first derivative.
Okay. I'm not sure exactly what that is.
Have you had the limit quotient definition yet?
No, not yet.
F of x plus h minus.
Yeah. We have done that. That's how you do derivatives, right?
That's first derivative, and they all end up working very similar to how you solve this problem. In other words, this is going to be the f of x plus h. This is going to be the f of x, and here's the h in the bottom, the thing that's going to 0. And unfortunately, with calculus, they force you to do your first derivatives the difficult method first, which is the limit quotient definition.
Which is the x plus h, f of x plus h minus f of x all over h.
Right. And the limit of that as h goes to 0. And those problems end up looking very, very much like this problem we just did. Every time you do one of those. And in fact, well, let's do one real quick.
Okay.
If I want the limit of 1 over x as x goes, hold on a second, not as x goes to 0, just a second. For some reason I got confused here. If I want the derivative, let's go back here for just a moment. If this is f of x, and I want to know what the first derivative of that is, that's the sign for first derivative.
Yeah.
Well, that is equal to the limit of f of x plus h minus f of x all over h as h goes to 0.
Okay.
And the way to do these problems is just go ahead and list out what f of x plus h is. What is f of x plus h?
1 over x plus h.
See our problem now? Is it going to be almost exactly like the last problem? We're going to have 1 over x minus h minus 1 over x all over.
Why would it be minus h?
What's that?
Why would it be x minus h?
My fault.
Okay. Sorry. I just was confused.
The unique thing about calculus is it's the first time you really run into x plus h. If you think back to all your algebra and pre-calc, everything's x minus h when you're dealing with, quadratics and conic sections and all of that. It's always x minus h.
Yeah, I also wanted to review that. Not today, but maybe next class. I really need to work on my trig. Really need to work on my trig because I know trig's like a really big part of calc.
What you know about trig is just to memorize what the derivative.
The trig identities.
And the trig identities. That's it. You really don't need a thorough understanding of the trig behind it. You just need to understand the trig identities and how to take the first derivative of the 6 trig functions. And you don't even have to figure out how to do it. You just have to memorize what they are. But we would do this problem very, very much like we did the previous one. The common denominators, h's are going to cancel out, and you're going to end up with negative 1 over x squared is the first derivative of that.
Yeah.
All right. That's probably a good place to stop. And let's see. Either you or your mother knows how to make an appointment on my site. And
I'll have my mom do that.
What's that?
I'll have my mom do that.
Okay. Yeah, and you can just go to my website and it shows you my complete availability and you can schedule.
Okay.
It only
Okay,
requires
perfect.
2 hours advance notice or even 1 hour, I think. But
Okay, cool. I will talk to my mom. I might need just maybe one more session before my test on Friday because I do want to do well because it's the first test.
that's fine.
So,
I got plenty of time this week. I really do.
okay, perfect. Is there any way you could maybe just something that I need help on, like just give me practice problems next class?
What do you need me to give you?
Maybe like 1 or 2 practice problems.
Okay, sure. I can definitely do that.
Okay, perfect. Thank you so much.
Okay, sounds good. Nice working with you.
Right.
Look forward to working with you again.
Yeah, definitely. I'll have my mom schedule another appointment, and I will see you soon.
Sounds good.
All right, bye.
Bye. To close out of the GoToMeeting, you just need to click on the X in the upper right-hand corner of that control panel, and it'll
Okay, perfect.
close you out. Okay, bye-bye.
Okay, bye.